dear students, cyclotron. In cyclotron, we are discussing cyclotron. Cyclotron important in working of cyclotron. So we got a few important expressions. So these are very important for doing numericals, right? So remember these expressions very important in cyclotron, right? First, gyro radius or cyclotron radius. Okay, R is equal to mv by qb. In last parts also we discussed it. Okay, the charge particle moving in uniform magnetic field. Okay, charge particle is moving perpendicular to the magnetic field. Radius. Okay, radius of the charge particle in a magnetic field is what? mv by qb. M is what? Mass of the charge particle. V is what? Speed of the charge particle. Q is the charge of the particle. B is a magnetic field. How we got this one? Centripetal force is equal to magnetic force. M square by R is equal to qb. From that R is equal to mv by qb we got it. Speed, from the speed how you can write it? Speed of the charge particle how you can write it? V is equal to BQR by M. Okay, V is equal to BQR by M. Okay, next, time taken by the particle to complete the semicircular path. Semicircular means half of the time of revolution. Okay, that is what? So semicircular path distance how much? Pi r by uniform speed V. That is what? So pi by V into R is mv by bq. Simplify you get pi m by bq. Next, time period of revolution is what? Time period of revolution is what? 2t. This is for half revolution, this much time. For full revolution, 2 into t. Okay, that capital T is what? 2 into t. That is 2 pi m by bq. Next, frequency of revolution, reciprocal of time period is called as frequency. Okay, bq by 2 pi m. This is also called as what? Cyclotron frequency or gyro frequency. Next, to angular frequency. Angular frequency is what? 2 pi multiplied by frequency of a charge particle or frequency of cyclotron. 2 pi into bq by 2 pi m gives a, so 2 pi get cancelled, bq by m. So what is the maximum kinetic energy here? Maximum kinetic energy of the charge particle, okay, in a cyclotron of mv maximum square. Of m, what is the v maximum here? So v maximum is a bqr by m. Substitute here, half m into bqr by m whole square, that is equal to b square q square r square by 2m. These are the important expressions for doing numericals in a competitive exam and a board exam. Okay, what are the uses of cyclotron? Cyclotron is used to bombard nuclei with energetic particles. Bombard nuclei with energetic particles. Okay, suppose we are taking this is a cyclotron mission. Okay, so this proton get a high energy. Cyclotron is what is a cyclotron? It is used to accelerate. Okay, high energy. Okay, now this proton got a high energy. So with the high energy, it is bombard a nitrogen molecule. Then it is split into what? Helium and carbon. Again, carbon is split into oxygen molecule. Okay. Then, so for which purpose? Study the nuclear reactions or bombard nuclei with energetic particles. Right. So cyclotron is used to bombard nuclei with energetic particles. Study nuclear reactions. Okay. This question very important board exam. Okay. Write any 2 uses of cyclotron. Write any 3 uses of cyclotron. Okay. So very important for board exam. Remember. Next, produce radioactive substances for diagnosis and treatment. Okay, so to kill cancer cells, we want gamma rays, correct? Na? Okay, so to scanning purpose, okay, we want radioactive rays. In that case, right? So we can use a high energy particle bombard with the radioactive element. Then it is produced what like alpha or beta gamma rays, correct? Na? Right? In that case, produce radioactive substances for diagnosis and treatment. So in that purpose also we can use a cyclotron. Okay. Next, implant ions into solids and modify their properties and synthesize new materials. Implant ions into solids. Okay, and modify their properties and synthesis. Okay, the ion, positive charge ion is placed at a source of the cyclotron. Okay, it maximum what happen? It gets a maximum energy. Okay, that maximum energy when is implant and the other ions what will happen? The properties of the ions is going to be changes. Okay, so these are the uses of cyclotron. Okay, remember, so very important. Okay, what are the limitations of cyclotron? The cyclotron has some limitations. So what are they? First one, the uncharged particles. Uncharged particle means chargeless particle. That is what? Neutron. Okay, so cannot be accelerated by cyclotron. Okay, the charge in cyclotron, principle of cyclotron, the charged particles accelerated by electric field, correct? No? Okay, so if the chargeless particle means there is no electric force. Chargeless particle means there is no electric force. Q is nothing but electric force is equal to E into Q. Okay, so there is no electric force. There is no electric force, there is no acceleration. Okay, in this case what happened? Electric force is equal to 0. Why? Because so Q is equal to 0. Charge of the neutron is what? 0. Then there is no electric force. Right? The uncharged particles, neutrons, that is neutrons, cannot be accelerated by cyclotrons. Why? Because neutron has no charge. The chargeless, the neutron is a chargeless particle. When it is placed at source, does not accelerate. Okay, so who creating acceleration? Electric field is creating acceleration. Okay, right, in a charged particle. So neutron is chargeless, there is no electric field, there is no acceleration. Correct? Na? The uncharged particles cannot be accelerated by cyclotron. Second one, light particles like electron. Electron mass is what? 9.1 in 10 power minus 31 kg. Mass of proton is what? 1.67 in 10 power minus 27 kg. Correct? So light particle, okay, electron mass, proton mass, which mass is more? Obviously proton mass. Electron mass is lesser than proton mass. What is electron mass? 9.1 10 power minus 31 kg. Correct? That's why electron is a lighter particle. So lighter particles also cannot be accelerated by cyclotron. Mostly the negatively charged particles are what? Lighter particles. The lighter particles are not does not accelerate a cyclotron. Why? So because mass of the electron is very small. Okay, a small increase in its energy causes the electron to move very high speed. Lighter particles, na? Okay, little bit energy increase, nothing but it should be escape from the chamber. Okay, we don't get up to what extent you want energy, we won't get that energy. Okay, if you give small speed, then it's come out from the chamber, right? So then, which particles can be accelerated in the cyclotron? Okay, therefore cyclotron cannot accelerate lighter particles. Then which particle? Only heavy particles. Heavy particles like which one? Protons, alpha particle, deuterions. Proton is 1H1. Alpha particle is 2 helium-4. Okay, deuterium 1H2. Okay, so these are what? Heavier particles. Understand? So these heavier particles can be accelerated by cyclotron. Okay, these are having charge. Understand? Not lighter particles comparing to electron, that is not lighter particles. These particles can be what happen? Accelerated by the electric field. Then these proton, alpha particle, deuterium. Okay, these are very important case in point of view. Which particles, following which particles are okay accelerated in cyclotron. These particles can be accelerated in a okay cyclotron. Which one? Proton, alpha particles, deuterium. Heavier particles can be okay accelerated in a cyclotron. Next, third one, what? The velocity of the third limitation is what? The velocity of the particle cannot be increased beyond a certain limit. Beyond a certain limit by cyclotron. Why? We know that radius of the charged particle in cyclotron is what? mv by vq. R is equal to mv by vq. V is equal to what? R qv by m. This speed depends upon R. Correct? Na? Charge is constant only. Magnetic field is constant. M is constant here. Correct? Na? Then it depends upon radius. Okay, beyond this up to this radius only possible. Okay, more than this radius not possible in cyclotron. Okay, up to this radius only the charged particle get a speed. Beyond this one, okay, charged particle does not get a speed in the cyclotron. Okay, the velocity of the particle cannot be increased beyond a certain limit by cyclotron. Next, very high kinetic energy also not possible. Okay, up to this kinetic energy is possible. Okay, beyond that is also not possible in the cyclotron. Okay, these are the limitations of what? Cyclotron. I hope you understood limitations of cyclotron. Okay, so by help of this example, by using this example, we can understand what cyclotron concept. See, a cyclotron's oscillator frequency is 10 megahertz. Frequency given how much? 10 megahertz. That is mega means 10 power 6. 10 megahertz means 10 power 7 hertz. What should be the operating magnetic field? So which was asking operating magnetic field, B is question mark. Okay, so then if the radius of its D's is okay, that is 60 centimeter. So R is 60 centimeter means 60 into centi means 10 power minus 2. 16 10 power minus 2 meter. What is the kinetic energy in mega electron volt? You should calculate kinetic energy of the proton being produced by the accelerator. For first, you can calculate what? So B. How to calculate B? So by using given data, how to calculate okay, B? You know that frequency is BQ by 2 pi m. From this what will get? So B is equal to 2 pi m into F by Q. Okay, so F is equal frequency of proton is what? Frequency of revolving proton is what? Frequency of cyclotron. Okay, so formula is what? BQ by 2 pi m. Then B is equal what here? 2 pi m F, 2 pi m into F by Q. 2 pi, so substitute the values here. So 2 into 3.14 into, correct na? So mass of proton how much given? 1.67 into 10 power minus 27 kg. 1.67 into 10 power minus 27. And so what is the frequency? Frequency is 10 power 7, okay, into 10 power 7 divided by, so charge of proton how much given? 1.6 into 10 power minus 19. Okay, so this you can simplify, you will get 0.66 Tesla. 0.66 Tesla. Okay, so next what is asking? Kinetic energy. Okay, for finding to find kinetic energy, we want speed. Speed is not given. You should find out speed. What is speed? Speed of the revolving proton. Okay, so speed of the revolving proton in cyclotron is what? 2 pi r by t, or else so speed is distance by time, right? So 2 pi r by t, or else what we should write? 2 pi r into 1 by t, nothing but frequency. 2 pi r into frequency. 2 pi r, 1 by t is called as frequency. 2 pi r into frequency. That is how much? 2 into pi value 3.14. Radius is how much given here? Okay, you can take out capital R. Okay, 2 pi r. So 2 pi r. 2 pi r into frequency. 1 by t is called as frequency. 2 into 3.14 into r value here 60 into 10 power minus 2. 60 into 10 power minus 2. And frequency is 10 power 7. 10 power 7. So this you can simplify. How much you will get, right? So you will get 3.78 into 10 power 7. How much you will get? 3.78 into 10 power 7 meter per second. So next you should find out what a maximum kinetic energy. What is how to calculate maximum kinetic energy? So maximum kinetic energy is what? Half mv square. Half mv square. That is equal to what? Half into. So what is the mass of proton here? Mass of proton is a 1.67 into 10 power minus 27 into speed. How much it is? 3.78 into 10 power 7. That is v square, nothing but 3.78 into 3.78 10 power 7 into 10 power 7 10 power 14. So this you can simplify, you will get the answer. So you should convert, first you will get the answer in joules. That joules you convert into mega electron volt. Okay, that is 1 mega electron volt is equal to how much given? 1.6 into 10 power minus 19 joule. 1 joule is nothing but 1 by 1.6 into 10 power minus 19 mega electron volt. So this complete value you divide with this answer, it is joules, no? 1 joule is equal to how many mega electron volt? 1 by 1.6 into 10 power minus 19. Okay, so that is divide with 1.6 into 10 power, so minus 13, sorry, so minus 13, then 1.6 into 10 power minus 13. Okay, simplify, how much will get, right? How much will get? That is 7 mega electron volt. How much it is? 7 mega electron volt. Okay, once again I am repeating, in this problem a cyclotron oscillator frequency is 10 megahertz, that is 10 power 7 hertz. What should be the operating magnetic field? Okay, so B, how we calculated? From frequency of proton is frequency of cyclotron, that is BQ by 2 pi m. So B is nothing but, so 2 pi m into F by Q. We substitute all the values, simplified, we got 0.66 Tesla. Next, for finding kinetic energy, we want speed. Speed is nothing but, in case of cyclotron, the particle is revolving in along the spiral path, nothing but maximum radius, it is a circular path. V is equal to circumference by time period, 2 pi r by time period. 2 pi r into 1 by time period is called as frequency. Then so we substitute all the values and simplified. We got the speed is what? Speed of the particle in cyclotron, 3.78 into 10 power 7 meter per second. Next, kinetic energy. Okay, so kinetic energy of the particle in that cyclotron is what? Half mv square, half into, so mass 1.6 into 10 power minus 27. So speed how much we got, that we substituted. Okay, divided by 1.6 into 10 power minus 25. Why? Because this is asking in mega electron volt. So we got in joule, the joule we convert into mega electron volt. 1 mega electron volt is equal to 1.6 into 10 power minus 13 joule. 1 joule is equal to 1 by 1.6 into 10 power minus 13 mega electron volt. Now this value divide with 1.6 into 10 power minus 13, then you will get the answer in mega electron volt. Therefore simplify, you will get the answer what? 7 mega electron volt. So frequency, so magnetic field is 0.66 Tesla and kinetic energy is what? 7 mega electron volt. Thank you.